Today's notes are on writing polynomial functions and models. For example 1, it says a metal worker wants to make an open box from a sheet of metal by cutting equal squares from each corner. If the length and the width prior to cutting out the corners is 16 inches and 12 inches, write a function for the volume of the box. Right, so first we need to think about the fact that we're taking off x inches from each side. So I'm subtracting 2x. So I know that one length would be 16 minus the 2x that would be subtracted off when I folded up those corners. The same thing is going to happen on the other side. I'm taking off 2x from the 12 inches. So this becomes 12 minus 2x. And since you are folding up that length, the height of your box becomes x. In order to write the function for the volume of the box, we're going to take our side lengths, x, 16 minus 2x, and 12 minus 2x, and we're going to multiply them together. I'm going to start with foiling the two binomials, and I'm going to leave the x out front, making sure that I have parentheses still to keep it separate. We'll get 192 minus 32x minus 24x plus 4x squared. Then I'm going to go ahead and combine like terms. I get 192 minus 56x plus 4x squared. Now I can go ahead and distribute x to everything. So I get 192x minus 56x squared plus 4x cubed. I'm going to finish by putting my answer in standard form, which is decreasing order by degree. So 4x cubed minus 56x squared plus 192x. Let's move down and look at example number 2. Example number 2 says the polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic meters of a shadow box. What are the dimensions in terms of x if the width is x plus 5? So if you want, you can draw a picture. You don't have to. So if we're drawing a box, right, so here's a sketch of my shadow box, and I know that the width has the dimension x plus 5, and I'm trying to find the length and the height. Since I already know the width and I know my polynomial function, I can use synthetic division to come up with another polynomial. So I'm putting negative 5 on the outside, and I'm going to use the coefficients 1, 7, negative 38, and negative 240. So if we go through our whole process of synthetic division, we'll get a new polynomial, and that polynomial would be x squared plus 2x minus 48, because we start our remaining polynomial 1 degree less than the original. So since the original was x cubed, when we use our bottom line here to write the coefficients, we start with x squared. This is now something that I can factor. Two numbers that multiply to 48 or negative 48 and add to positive 2 would be a positive 8 and a negative 6, which would give me my other two factors. So we could say one side would have been x plus 8, and the height might have been x minus 6. So the dimensions of my box were x plus 8 by x minus 6 by x plus 5. We will look at the other two examples tomorrow in class.